Hey, I've been getting so many questions lately about lab quality and oil analysis. It's fascinating how people from all over the world reach out with concerns about their test results.
Yeah, I hear that a lot. Just yesterday, someone was asking me why they got different iron readings from two different labs. It's actually a really common concern.
And you know what's interesting? These questions come from both small companies and major industries alike.
Well, there's this interesting misconception that if something's printed on a lab report, it must be absolutely correct. But that's not always the case. Like, I've literally seen oil samples with visible metal particles showing just 1 ppm of iron on standard tests.
Oh, wow, that's quite a difference. So, how do we know what's actually right?
It comes down to understanding test limitations. For example, most labs use something called ICP testing, which is terrible at detecting large particles. That's why we developed our own method called LubeWear, which gives much more accurate results.
Could you explain a bit more about how ICP testing works?
Sure, ICP basically atomizes the oil sample and measures the light emission from different elements, but it can only detect particles smaller than about 5 to 10 microns.
Mm-hmm. And what about those larger particles?
They just settle to the bottom of the test tube and never make it to the analyzer. That's why you can have visible metal but get low readings.
Interesting. And I guess sampling plays a big role too, right?
Exactly. People often think if they take two samples back to back, they'll get identical results. But even professional labs struggle with this. Think about it. Mixing a 100 milliliter sample bottle is easy, but trying to get a uniform sample from a 10,000 liter tank, that's a whole different story.
I've heard some people say they just grab a quick sample from the top of their tank. That's not ideal, is it?
Oh gosh, no. You really need to flush the sample point first and take the sample while the equipment is running, if possible.
And at operating temperature too, right?
Absolutely. Temperature makes a huge difference in how particles are distributed throughout the system.
That makes sense. So what about quality control in labs? How do they ensure accuracy?
Well, there's something called reproducibility, which means getting consistent results even when different people run tests on different days with different equipment. A good lab aims for results within about 10% of each other, 95% of the time.
And they use reference materials too, don't they?
Yes, but even reference materials have their limitations. They come with their own uncertainty values.
That's something most people probably don't realize.
But that still leaves room for error, right?
Absolutely. Even with the best quality controls, some tests are just inherently less accurate. Take the total acid number test. It has a whopping 44% margin for error. That's why experienced diagnosticians are so important. They can spot when something looks off.
What other tests tend to be less reliable?
Water content can be tricky, especially in fuels. And dissolved gas analysis is super time sensitive.
And I suppose samples can change over time too.
Oh, definitely. Some fluids absorb moisture from the air. Others have ongoing chemical reactions. It's not like putting something in the fridge where it just stays the same.
That's why quick turnaround time at labs is so important, right?
Exactly. And why proper sample storage is crucial. Temperature, light exposure, even the type of bottle can make a difference.
This is really eye-opening. What should people do to make sure they're getting reliable results?
Talk to your lab. Ask about their quality processes, their proficiency testing scores, what we call Z-scores. A good lab should be transparent about their methods and willing to explain their quality control measures.
And don't be afraid to ask questions if something seems off.
Never. A good lab would rather explain their processes than have customers doubting their results.
It's amazing how much goes into ensuring accurate oil analysis. Seems like there's a lot more to learn about this topic.
There sure is. If anyone wants to dive deeper into oil analysis, they should check out learnoilanalysis.com. We've got tons of resources and training materials that cover everything from basic testing to advanced diagnostics.
Yeah, it's definitely worth checking out, especially if you're responsible for equipment reliability or maintenance decisions.
Exactly. Understanding oil analysis can literally save millions in equipment costs and downtime. It's pretty incredible stuff.
And it's not just about the big industrial equipment either. Even smaller operations can benefit from proper oil analysis.